Hello everyone, here we are back again. We're going to see if we can make some more progress on this beast. If you want to see my impatience, see whether it pays off or blows up in my face, stick around. We're gonna see what happens. We're gonna kick this pig. All right, before we get started, let me say that if this is your first time here, please do me a favor and click the subscribe button. And if you'd like to get notifications for any future content that gets uploaded, go ahead and ring that bell, and that way anytime I add content to the channel, you'll get notified. But at a bare minimum, please at least click the subscribe button and help me build the channel. I'm trying to make it grow. You're also going to see in different places, you're going to see some QR codes on the screen. Feel free to check them out. I put them on there so that it'll make it more convenient for you. One of them is GearBest affiliate link, and the other one is a link to filament deals. You can take your phone, hold it up to the screen, scan the QR code, and bam, it'll take you straight to the filament section on Amazon, or take you straight to GearBest. And if you purchase anything from either of those links or anywhere on Amazon, if you go through that link, it'll send a few cents to the channel. So I'd appreciate anything you can do there. That being said, let's move forward and start tearing into this thing. Okay, so let's get started with this. What I've got is a rocker switch that I have scavenged out of something, some piece of equipment. I don't know what, but it was in one of my junk boxes. And I want to put a power switch in the side of this box. So I've already measured this. 25 millimeters by 28 millimeters square hole is what I need to do for this power switch. So I took my calipers and I transferred that measurement on the side of this sheet metal box, and we're going to see if we can get a nice cutout for that and get this power switch in. So first thing I want to do is keep as many shavings off the floor as I can. And I'm going to take this unibit. Let's see if you can see it there. I think you can. Take this unibit and we're going to hog out as much of that square as we can. So we can get our nibbler in there. So let me drill this out real quick. That ought to be good. Okay. So actually, I don't want to throw those away. Okay. So now let's see if we can nibble this out. Let me see if I can get it back on camera here for you. So that gets us to the edge, and then we're just gonna slowly chew our way around the perimeter of this square hole. Let's see what one more gets us. I think that'll get there. Okay. Let's go one more. Okay. This nibbler does such a better job and makes a nice square hole, cleaner cut. Let me get that piece out of the way. Works really well. Alrighty, I think that'll get that one. Let's do one more. Okay. There we go. Nice square hole. Those are handy little nibblers if you're going to be doing something like this. Works perfect. You couldn't do that. It'd be a lot of work if you wanted to drill a hole. Use tin snips or a file or whatever and clean it up. So definitely recommend those if you think you're ever going to be doing anything with sheet metal or thin plastic. Let me get rid of these shavings real quick. Okay. Now, for the moment of truth. Will she fit? Looks like we need to go just a hair bigger. We'll make one more pass. Height-wise. There we go. Now let's see what we got. Is that better? It is better. Voila! We have our power switch. So that's some progress. Alrighty. So now we've got our power switch in there. We need to work on the power supply. And I got a little bit of bad news on the power supply at the moment, but we're going to work around it. Somebody had given me a power supply and told me it was good. So I took the time, modified the wiring harness, went in and cut out a bunch of the wires that I wasn't going to need. Got it all trimmed up. And I was an idiot. I didn't test it first. This is a bad power supply. I opened it up and looked through it. I don't see anything obviously wrong, not a blown fuse or anything like that. So we're not going to be able to use this one. And at the moment, I've only got a little bitty one. But I know this one works. So just for some temporary testing and make some progress, I want to see something. Move forward. I've run into a few snags on the frame that I'm not happy with, so we're gonna have to work those out. So I decided I'm gonna move over and try to make a little progress here in the control box. So what I've got here is just a little, what is it, 150 watts, but my heat bed is going to be 110, so this should be enough. Well, actually this power supply won't even be in there when I get ready to hook the hotbed up, so that doesn't matter. We're just going to hook this up temporarily and use it to test. So I'm not even going to bother with cutting out all the wiring harness. What I'm going to do is just tie it up. Okay, but one thing I am going to do is hook my power switch up. So I will tell you that in these ATX power supplies, really, there's only a couple wires here that you got to worry about, really. And I'm going to do a separate video on the ATX. I know there's a bunch out there, but I'm going to do a separate one on it, on these power supplies, of how to use them. So basically all I'm going to do is I'm going to take the green wire. It's the only one in the, this is a 20 pin plug, but some of them have a 24 pin plug. I'm going to take this green wire and I'm going to take one of the blacks. All the blacks are ground in this one. Probably this is pretty much standard across the board from what I've seen in videos, but I can't guarantee it. But I do know this one, black is the ground. And I'm thinking, no, this is fan control here for that one. I was going to say there is one other green wire on this power supply, but anyway, let's see. Here is my black and green wires. Alright. So we're going to give this a test run here. Let's see. Okay, and crimp-on connectors. Make sure it fits, and it does. And let me just do a double check on the switch. Because I actually didn't. Now I think this is just a double switch, 2-pole. So there it's closed. And it's open. Okay. Same on the other side. Okay. So, good news, bad news. The good news is the switch is going to work just fine. Yeah, I'll leave those out. Bad news is, my luck, typical, I put it in upside down. I want it up is on and down is off. So we're going to flip that sucker over. Alrighty. Okay. So we got that. Switch is orientated in the right direction. Put a couple crimp-on connectors in here. There's one. There's two. Okay, so let's do a test on this, make sure she's going to work. Let's go this way. And what we have here, what this green and black is this is a remote on-off switch for a computer. Wow, that's tight. It should fit. Yeah, there we go. It's just tight. Tight is good. Okay, and we're going to carry the black around here. Yeah. Alright, there's the black. And there's the green. Okay, so actually let's spin this around this way. We're still on camera. Yep, we're good there. And I should have a power plug around here. So let's give this a shot. Let's see how she works. Okay. Switch is down. We should have no power. Okay. No fan. Now let me rephrase that. This thing has a light. It shows we have power coming to the power supply, but no output. Now, when I turn the switch on, hopefully this fan will come on and we will have some output. And there she goes. All right. So we're good there. Okay, let's see. What do we want to do next? Next, I think what I want to do is I want to take and cut. Don't need as much of that as I have to work with. So, and what we have here is we've got black, yellow, and red. The red should be 5 volts, and the yellow should be 12 volts positive. Let me double check that. Red positive 5 volts, 16 amps. Black is the ground, and yellow is positive 12. Okay, so we're going to use one of the blacks. And again, keep in mind this is just temporary. I'm just impatient and want to see something happen. Okay. And now, let's see, one hook. Ground up. Okay, and we have a power supply. So we'll let this sit in here for now. Okay, now let me get this display thing plugged back in where I knocked it loose. Two. Okay. There's one. And there's two. Okay. Alright, I think we're good. Okay, so now, the next thing we need to do is, let's play with some firmware. See if we can get this Arduino loaded up. Okay, so now we're going to start on firmware a little bit here. Clean up my mess. Okay, so we're going to need a USB cable. Alright, USB A, USB B. And we're in. Okay. Oop, she connected. So, let's see what we have here. Alright, let me get this screen switched over so I can share my screen so you can see what I'm doing. Alrighty, so here we are. Let's go get the firmware. So we're going to go to, let's see, download. Actually, let's just do this. Let's go to marlinfirmware.org. There we go. And let's go to download. And let's download the latest version, which is 1.1.9. We'll download and save that. And there we have it. We do. We have it. So, let's go. Let me shut this down. Okay, so I've downloaded the firmware. Let's go to the download folder. Down here to the Marlin. Let's extract. Oops. Let's extract it to a folder on the desktop. And extract all the files. I didn't want to do that. Okay, so she's extracting. We should end up with a little folder here. There she is. And looks like we're done. So now we're going to go in here to the Marlin folder. And there we go. Okay, so we'll open up the Marlin. We're going to look for Marlin. INO right there. We're going to open that file. I have Windows 10, so the Arduino IDE was already in it. If not, you can download it easy. Okay, so here we go. Let's see. Let's go through here and configure this machine. We're going to go to configuration H. Configuration.h. And again, I'm sure there's a ton of videos out there on this. I've seen several, so we're just going to go through here and hit the basics. Just enough to get it fired up. Let's just kind of scroll down through here and see what we can set. Boot screen, splash screen, website. That's all already set. Show custom boot screen, the machine, the baud rate, the Bluetooth. Okay. So, nothing there I want to change. Baud rate, I'll leave that alone. Motherboard, I do have the ramps 1.4. You can look, there's different options. If you go over here, there should be a folder called boards.h, and look down and here's all the options. Like here's all the options for ramps 1.4. If you got a hot end, a fan, and a bed, hot end 0, hot end 1, and a bed, different configurations. All I'm going to have is hot end, fan, and a bed. So the default works perfect for me. So let's go back here to configuration H. And that motherboard looks good. Custom machine name. 3D printer. Let's change that to Ed's printer. Just for the heck of it. Okay, let's see. I'm not going to worry about machine name. Extruders, I got one. Single nozzle. Default filament. 1.75. And let's go on down through here. I'm not going to mess with any of these other things right now. I don't even have the machine built, so we can go back and fine tune those later. Power supply switch. I'm not going to have. I've got a manual switch we just installed, so no power switch coming from the control board. And that's what I believe what that is, so that you can have your control board turn on and off the power supply. Thermocouple, thermistors. I'm going to leave that because I believe that's what I have. The bed temp sensor. I don't have that stuff yet, so what I'm going to do is I'm just going to make that I'm going to plug in one of these dummy values, and we're going to make the bed sensor no, we're going to leave it the way it was. 0, not used. There we go. Temp sensor 1. And we'll see what happens. Okay. Let's go down through here. PID settings, I ain't worried about right now. Bed limits. Bed limits. I don't have those on yet, so what we're going to do, if I understand this correctly, they're set up for normally closed switches to allow it to move. And I'm going to invert them just so I can move it around without any switches at all, and then I'll put them back once I get the switches mounted. And I'll just have to be careful not to crash it. That's all. Okay, so we're setting there. Sitting good. Okay. Specify stepper types. Okay. I have A4988s came with the ramps board, so those are all preset. That was handy. Okay, now we're going to define the axis steps per millimeter. So my motors are 200 steps per revolution. 1 revolution on my lead screws is 2 millimeters. So for 1 millimeter, I would have half a rotation, which is going to be 100. 100 steps per millimeter.
Okay. Then I also have to take into account that I have set the jumpers. When I put the board in, I set the jumpers underneath the drivers to 16 micro steps. So that means I need 16. Was going to be 100 steps per millimeter. I created 16 microsteps, so it's going to be 1600. Should be 1600 steps per millimeter. And I'm using the same lead screws on all three axes. And then I'm going to go ahead and set the extruder there too, just to keep them the same for now. Default max feed rate 300, 300, 5 on the Z, and 25 on the extruder, and we'll leave it. Okay, and acceleration we're going to leave. The jerk we'll leave. Z probes. BL touch, bed leveling, I don't have any of that right now. Alright. Size of the print bed. It's hopefully going to end up at 500, but let's leave a little bit of room. Let's call it 400 by 400. And then on the Z 400. Okay. So let's see. We can always change it later. I'm sure I'm going to have a ton of debugging to do. But I just want to see if this thing will come alive, or am I wasting my time and need to do something different. Okay. I think that's about no, the display. We gotta configure the display. English, yeah. I don't have any SD card support right now, so you don't have to worry about that one. Encoder settings. Let's see, this, I think this is the encoder on direction everywhere. Set the option for clockwise, causes values to decrease. Reverse encoder direction. Menu direction. If clockwise normally moves down, this makes it go up. Clockwise goes down, that makes it go up. And we'll leave it. We'll see what it does first and then go back and adjust it. Okay, and got to figure out which controller I have. I know I've got the 128 by 64. .128 by 64 right there, that's the one. Okay, so important, it needs this library for the graphical display. Okay, we'll deal with that later. So we're going to uncomment the full graphics display. Did I do the right one? Let's see, graphical 128 by 64. Important. Rep. There's the definition to find that controller. Okay, so that should be good. There's tons of controllers. This thing's made to fit about any machine that you're going to have, so in servos. So I think we're good there. Let's see what it does. And we're verifying the program. Oh, you know what I did not do? I did not see a place that says to set the Arduino 2560. Let's let it finish compiling and we'll see what we got. It's recognizing the board down here in the corner. It says Arduino Genuino Mega or Mega 2560 at Mega 2560 on COM4. So it sees the board. That's a good sign. No smoke came out. That's another good sign. Come on, Pokey. She's still verifying. Compiling sketch. I don't have a lot of experience with this. I don't have any experience with this. Actually, I've just watched a lot of videos. Done compiling. Okay. Let's see. I told it that it was ramps. Okay, let's go over to, well, let's see what we got here. Maybe that's in the upload. No. First I need to go add that library. Where was that library at? Man, this thing has a lot of stuff. I could make a mess of this real quick. Boards. Well, it'll probably tell me. Let's see what it does. Okay, so if I click the upload, what's it gonna do? Upload? No upload. Edit. Sketch. Verify. Upload. Include library. There we go. There we go. Come on. Manage libraries. Okay, and that was, what was it? U8G? Something? U8G. There we go. U8G library right there. Okay, select version. No, that's the only version I see. Install. Okay, so there's the library. And tools. Board at Mega 2560, COM4. Looks like we're all good. Okay, so upload. Compiling sketch again. We're hooked up. Yep. We're hooked up. Oh, it's got to recompile probably because I added that library. Okay. Waiting. It's about halfway done. Uh-oh. Uploading. Okay, we're good. Upload done. Okay. So, let's take a look at what we got. Let me switch out of this. You can go back to this screen and let's see what we got. Okay. So, I'm going to unplug this because just in case I did something wrong, I don't want anything blowing back into my computer. And switch back to the overhead mic. That's any better for now. Done. Okay. So, nothing blew up. Let's see if she'll power up. Cross your fingers. We have light. And it says Marlin 1.1.9 3D printer ready. Hey, I thought I changed that to say my 3D printer. Okay, so let's click on here. I don't know if you guys, can you see that? I don't have anything really to bring that camera down closer, but I've got info screen, prepare, control, temperature, motion, filament, restore failsafe, main, prepare, axis, all the movements, auto home, set home, disable steppers, preheat, preheat. By golly, we're making progress. Okay. So I'm going to stop it here and get the frame back up here on the table and we'll go from there. Okay, and we're back. I got the frame back up on the table. We've got our controller here sitting next to it. Power's off. Let's start out slow. I got my motor leads here, which I will tell you ahead of time. I've been verifying from the prints and different things when I was sitting in the living room tinkering, and I do know that these motor lead extensions that I bought off of Amazon, the pinout is different.
which I've seen other people have trouble, so that's why I kind of verified the printout or the pinout ahead of time. And I didn't think, and I went ahead and I swapped the pins around without doing it on camera. But I'm just telling you ahead of time, I did not just buy these and plug them in and they were good to go. I had to swap pins around so that they were all in line. Basically, I don't know if you're familiar with a crossover cable for like Cat 5. You got, it's like a crossover and a pass-through. I don't remember, but sometimes they cross the send and receive signal wires. This was similar to that. All I had to do was pop the pins out and basically just make it a straight pass-through. So if black was on the right on this one, black was on the right on this one. Now it also, you got to keep in mind which direction you're looking at the motor and which direction you're looking at the board, but just verify that very carefully before you get started. Now let's hope that it works. Let's see here. Let's start with this motor close and see if it'll move. One step at a time. I don't want to do them all at once. So I want to keep the suspense going in case some of the smoke gets out. All right. So there's X, Y, and Z. All right, there's a Z. Let's see if it'll work. All right. Power on, printer ready. Go down to prepare. Let's see if you can see that. Okay, let's go to move axis. Uh-oh, there she goes. That was weird. Prepare. Move axis. I don't know what I did, but it didn't smoke. Z. Let's go 1 millimeter. Oop, she moved. She moved. Okay. We'll go back. Yep. All right. We're cooking with gas here. Oh, shoot. You can't really see that, can you? Okay, let's turn this back off. Let's try another one. Let's see. Let's try another one. Let's go ahead and hook the other Z up. Oh, that ain't going to reach, so we won't do that one yet. I got to make up a longer cable for that one. And I'm just going to take 2 of these and cut the opposite ends off and solder them together. So let's try this one. I'm afraid of this one. I'm afraid of this one because I'm not sure it's going to have enough torque to push through my homemade bearings. But what the heck, we'll give it a try. Well, I have put myself into a corner here. Let's see, you can't see me here, so let me see if I can change this camera over a little bit. Okay. No. So I'm gonna move the table a little bit. How about that? Now you can see me a little bit. Okay, so let me see. This is the y-axis. Power is off. Okay, there's the y-axis. Now let's see what we get. I'm on 1.9. No smoke. Again, prepare, move axis, Y, 1 millimeter. Oh, she moved. She moved. We'll go back. Can you see that? Let me see if I can get this camera down where you can see it better. I don't know if I can or not. Hang on, it's gonna get dizzy. I gotta get a stool, I'm not tall enough. Oh, I'll be glad when I get some good cameras and good mounting equipment for it. Okay, hang on. I'm sorry if you're getting dizzy. Just trying to get you a closer picture. So, let's see what we got here. Will it go big enough there? It will. All right. Should be able to see that. So, doesn't sound the same as the other one though. Let's see. And I should have turned the knob around. I don't like the direction it goes, but that's okay. I can fix that. So let's go back to the Z. And let's go to 10 millimeters per click. That's sweet. That is sweet. Go back. Perfect. Now, while I'm at it here, let me see if I can. I'm going to move the camera again, so hang on there with me. One thing I regret, and that's these couplings. I do not like these couplings at all. Now, part of it is my unsquare and crooked sheet metal brackets, but I just have to make the best of what I got. Once I get everything to where I can 3D print proper brackets and everything will be square and tight, I'm going to get different couplings. I do not like these spring couplings. And I was talking to a guy on Facebook about having the motors on top. My thinking for having the motors on top would be I could put a heat sink up here and there'd be more air movement and stuff. That was my thought process on that. But now I wish I would have put the motors on the bottom. And so instead of pulling down on this springy coupling, which I was going to put a support at the bottom of the lead screw to prevent that. I haven't got that far yet, but I may redo that and put the motor on the bottom anyway, because I'm not happy with the mount. I'm not happy with the really I'm not happy with several things, but anyway, I would never buy those couplings again. I don't want those spring couplings. They've been on there and just sitting, not being used, and you see that they've retained the bend in them. They're crooked. Let me run it. You can see the wobble in it. But she's motivating, so that's good news. Okay, now let's see if I can. Wonder if I can do this. No, I can do this. Maybe if I'm strong enough. That's better. Let's see if that, no, that ain't better. That is not better. Now I can't bend down enough, so let's see if I can do that. Then I'll probably click and fly off and hit me in the head and everything else. Okay, so now we're back on the y-axis. Let's go back to the y-axis because it doesn't sound the same. Y-axis. Well, it doesn't do me any good to hold that lid down now because you can't see it, but I'll go to the y-axis and let me go to 10 millimeters per click. Yeah, no, that's not it. Okay, now I was afraid of that. Yeah, she was in a bind there a little bit. Let's see if it's going to go this way. It's pushing. Nope. Okay, so I got some issues there. Let's see what else I got. Okay, so let's try. Let's shut her down. And I'm going to put another motor lead on there. Let's try the x-axis. Nope. I dropped it. Okay. All right. And will it reach? Barely. X-axis. That wire looks weird. I don't think it's seated up in there all the way. But I guess it is. Okay. That was the y-axis. This is the x-axis. Okay. Okay, now let's try it again. Let me see if I can move this camera. And we move the camera to see it. Probably not. Here's the shaft. Okay. Let me put a piece of tape on there. So we can see it move. Okay. So we've got the x-axis plugged in. Let's turn it on. One millimeter. Can I move this? I bet I can. Yeah, let's move that out of the way. Yeah, see, that's going to be too much drag. I've got some work to do. You must have a timer if you don't move. Okay, so I must have some issues somewhere in the firmware, because if I go to 1 millimeter per click, let's start there. Let's say that's 9 o'clock position. Alright, so I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this thing's 11 millimeters is 1 revolution, and 1 revolution in reality is only 2 millimeters on a lead screw. So I've got something in my formula, something wrong. Something configured wrong, but I don't care. That's an easy one to work on. I got all 3 axes moving. Got all 3 axes moving. I did not check this one, but it won't reach, so I can't. And it won't reach the extruder right now. So, but anyway, that's progress. That makes me happy. That makes me happy. Still got a lot to do. I love the frame. Frame's solid. Frame's pretty square. I'm happy with that. Controller's got firmware in it. Has power. I'm happy with that. That's all working. Just a little customizing in the firmware, and I've got that where I want it. I do have to find another ATX power supply because I don't want to use this little bitty thing, but for now, for testing, I'm not running the hot end or anything. So things I have to improve on. The drag. I was afraid the drag was going to be a lot on these bushings. I know I'm straight. I know my alignment's good because I have run this by hand all the way back and forth. I know my alignment is good. So it's just got to be the fact that my bushings are too tight. I know this one's too tight, but I wasn't finished with it yet, so see here. I know that one's tight. I even took one bushing out and left 3 to cut down on some of the resistance. So I got to come up with a new bushing plan for sure. And I think I'm going to have to come up with a new carriage. I don't think I like this. Let's see if I can do this without unplugging the camera. I think this is too rickety. I got a piece that I was going to use to stiffen it, but I'm afraid by the time I get done stiffening this thing, it's going to be too heavy. So I got to come up with a new plan. New plan. And I'm also not liking the fact that my lead screws are not in line with my rails. I got a feeling that's going to cause it to want to bind. So I got to redesign that too. Got to redesign it. The motor leads, definitely do your pin out before you put those on. That helped. That worked perfect. Do not buy these spring couplings. They suck. I do not like them at all. I think we've gone about as far as we can go today. I did order my Bowden tubing. It should be here in a couple days off Amazon. Not that it matters right now, but I didn't want to, if everything would have gone perfect, I didn't want to be sitting here waiting on some stupid tubing. But yeah, I think we're going to wrap it up with that. It's progress. Motors are turning. Now I got to work on the mechanicals. I got to make that better. So I think I'll call it here and say goodbye. I'll see you soon. And we'll make some more progress. So check back soon and see what we come up with next. I just want to thank you for coming and watching my video, and I hope you'll check back soon and keep up with the progress on this project and other projects to come in the future. So if you would, please go hit that subscribe button, and if you want notifications, ring the bell, and then when I add the next segment to the video series, you'll get notified. So thanks for coming, and check back soon. See ya.